What is the difference between Venv, Pyvenv, Pyenv, Virtualenv, Virtualenvwrapper, Pipenv, etc.? Python 3.3 includes in its standard library the new package venv. What does it do, and how does it differ from all the other packages that match the regex, py, v virtual pip, env? This is my personal recommendation for beginners. Start by learning Virtualenv and pip, tools which work with both Python 2 and 3 and in a variety of situations, and pick up other tools once you start needing them. Now on to answer the question, what is the difference between these similarly named things? Venv, Virtualenv, etc. PyPI packages not in the standard library. Virtualenv is a very popular tool that creates isolated Python environments for Python libraries. If you're not familiar with this tool, I highly recommend learning it, as it is a very useful tool. It works by installing a bunch of files in a directory, e.g., env/, and then modifying the path environment variable to prefix it with a custom bin directory, e.g., env/bin/. An exact copy of the Python or Python 3 binary is placed in this directory, but Python is programmed to look for libraries relative to its path first, in the environment directory. It's not part of Python's standard library, but is officially blessed by the Python Packaging Authority. Once activated, you can install packages in the virtual environment using pip. Pyenv is used to isolate Python versions. For example, you may want to test your code against Python 2.7, 3.6, 3.7, and 3.8. So you'll need a way to switch between them. Once activated, it prefixes the path environment variable with /.pyenv/shims, where there are special files matching the Python commands, Python, pip. These are not copies of the Python shift commands. They are special scripts that decide on the fly which version of Python to run based on the pyenv_version environment variable, or the .python version file, or the /.pyenv/version file. Pyenv also makes the process of downloading and installing multiple Python versions easier using the command pyenv install. Pyvenv is a plugin for Pyenv by the same author as Pyenv, to allow you to use Pyenv and Virtualenv at the same time conveniently. However, if you're using Python 3.3 or later, Python-venv will try to run Python-venv if it is available, instead of Virtualenv. You can use Virtualenv and Pyenv together without Python-venv if you don't want the convenience features. Virtualenvwrapper is a set of extensions to Virtualenv, see docs. It gives you commands like Virtualenv, site packages, and especially warcon for switching between different Virtualenv directories. This tool is especially useful if you want multiple Virtualenv directories. Python-venv is a plugin for Pyenv by the same author as Pyenv, to conveniently integrate Virtualenvwrapper into Pyenv. Pipenv aims to combine pip file, pip, and Virtualenv into one command on the command line. The Virtualenv directory typically gets placed in /local/share/virtualenv/xxx, with xxx being a hash of the path of the project directory. This is different from Virtualenv, where the directory is typically in the current working directory. Pipenv is meant to be used when developing Python applications, as opposed to libraries. There are alternatives to Pipenv, such as Poetry, which I won't list here since this question is only about the packages that are similarly named. Standard library. Pyvenv, not to be confused with Pyenv in the previous section, is a script shipped with Python 3.3 to 3.7. It was removed from Python 3.8 as it had problems, not to mention the confusing name. Running Python 3.venv has exactly the same effect as Pyvenv. Venv is a package shipped with Python 3, which you can run using Python 3.venv, although for some reason some distros separate it out into a separate distro package, such as Python 3.venv on Ubuntu/Debian. It serves the same purpose as Virtualenv, but only has a subset of its features, see a comparison here. Virtualenv continues to be more popular than Venv, especially since the former supports both Python 2 and 3.
I would just avoid the use of Virtualenv after Python 3.3+ and instead use the standard shipped library venv. To create a new virtual environment you would type. Virtualenv tries to copy the Python binary into the virtual environment's bin directory. However, it does not update library file links embedded into that binary, so if you build Python from source into a non-system directory with relative path names, the Python binary breaks. Since this is how you make a copy distributable Python, it is a big flaw. BTW to inspect embedded library file links on OS X, use OTool. For example, from within your virtual environment, type Consequently, I would avoid Virtualenvwrapper and Pipenv. Pyvenv is deprecated. Pyenv seems to be used often where Virtualenv is used, but I would stay away from it also since I think Venv also does what Pyenv is built for. Venv creates virtual environments in the shell that are fresh and sandboxed, with user-installable libraries, and it's multi-Python safe. Fresh, because virtual environments only start with the standard libraries that ship with Python, you have to install any other libraries all over again with pip install while the virtual environment is active. Sandboxed, because none of these new library installs are visible outside the virtual environment, so you can delete the whole environment and start again without worrying about impacting your base Python install. User installable libraries, because the virtual environment's target folder is created without sudo in some directory you already own, so you won't need sudo permissions to install libraries into it. Multi-Python safe, because when virtual environments activate, the shell only sees the Python version, 3.4, 3.5 etc., that was used to build that virtual environment. Pyvenv is similar to Venv in that it lets you manage multiple Python environments. However, with Pyvenv you can't conveniently roll back library installs to some start state, and you will likely need admin privileges at some point to update libraries. So I think it is also best to use Venv. In the last couple of years, I have found many problems in build systems, Emacs packages, Python standalone application builders, installers, that ultimately come down to issues with Virtualenv. I think Python will be a better platform when we eliminate this additional option and only use Venv. Edit, tweet of the BDFL. I use Venv, in the stlib, and a bunch of shell aliases to quickly switch to Virtualenvwrapper, Pyvenv, October 22, 2020.
Update August 25, 2020. Added below, conclusion, paragraph. I've went down the Pipenv rabbit hole, it's a deep and dark hole indeed, and since the last answer is over 2 years ago, felt it was useful to update the discussion with the latest developments on the Python virtual envelopes topic I've found. Disclaimer. This answer is not about continuing the raging debate about the merits of Pypenv versus Venv as envelope solutions. I make no endorsement of either. It's about Pypa endorsing conflicting standards and how future development of Virtualenv promises to negate making an either/or choice between them at all. I focused on these two tools precisely because they are the anointed ones by Pypa. Venv. As the op notes, Venv is a tool for virtualizing environments. Not a third-party solution, but native tool. Pypa endorses Venv for creating virtual envelopes. Changed in version 3.5, the use of Venv is now recommended for creating virtual environments. Pipenv. Pipenv, like Venv, can be used to create virtual envelopes but additionally rolls in package management and vulnerability checking functionality. Instead of using requirements.txt, Pipenv delivers package management via pip file. As Pypa endorses Pipenv for package management, that would seem to imply pip file is to supplant requirements.txt. However, Pipenv uses Virtualenv as its tool for creating virtual envelopes, not Venv, which is endorsed by Pypa as the go-to tool for creating virtual envelopes. Conflicting standards. So if settling on a virtual envelope solution wasn't difficult enough, we now have Pypa endorsing two different tools which use different virtual envelope solutions. The raging GitHub debate on Venv versus Virtualenv, which highlights this conflict, can be found here. Conflict resolution. The GitHub debate referenced in above link has steered Virtualenv development in the direction of accommodating Venv in future releases. Prefer built-in Venv. If the target Python has Venv, will create the environment using that, and then perform subsequent operations on that to facilitate other guarantees we offer. Conclusion. So it looks like there will be some future convergence between the two rival virtual envelope solutions, but as of now Pypenv, which uses Virtualenv, varies materially from Venv. Given the problems Pypenv solves and the fact that Pypa has given its blessing, it appears to have a bright future. And if Virtualenv delivers on its proposed development objectives, choosing a virtual envelope solution should no longer be a case of either Pypenv or Venv. Update August 25, 2020. An oft-repeated criticism of Pypenv I saw when producing this analysis was that it was not actively maintained. Indeed, what's the point of using a solution whose future could be seen questionable due to lack of continuous development? After a dry spell of about 18 months, Pypenv is once again being actively developed. Indeed, large and material updates have since been released.
January 2020 update. Pyvenv has explained all the differences very well. Generally, we want to know the difference between all tools because we want to decide what's best for us. So, the next question would be, which one to use? I suggest you choose one of the two official ways to manage virtual environments. Python packaging now recommends Pypenv. Python.org now recommends Venv.
If you want to support the channel, please consider liking and subscribing.